right, we are on section 9.1, example 4, which is called Rationalize the Denominator. So in math, when we're working with these expressions, an expression is not simplified fully until there are no radicals in the denominator. So a radical includes a square root in the denominator, it could be a cube root in the denominator, and the problem is not simplified fully until those are removed from the denominator. So the way that we get the square root or the cube root, any type of radical out of the denominator, is we will multiply both the numerator and the denominator by a radical expression that will get rid of that. So I'm going to go through both of these examples and I think you'll pick up on it pretty quickly. In letter A, we have the square root of 5 divided by the square root of 3n. So this right now, the square root of 3n in the denominator is what I need to get rid of. So I'm going to multiply both the numerator and the denominator by the square root of 3n. And the reason that this is okay is that the square root of 3n over the square root of 3n is equal to 1. So I'm basically just multiplying this expression by 1, but it's going to help me get rid of that square root in the denominator. So when I do this, the square root of 5 times the square root of 3n is the square root of 15n. And then in the denominator, I have square root of 3n times the square root of 3n gives me the square root of 9n squared. Now I still have that square root in the denominator, but what you'll notice is that we have some perfect squares in there that are going to simplify fully. So on top, I still have the square root of 15n, but on the bottom, square root of 9 is 3, and the square root of n squared is n. So this is my final answer, and this is now simplified all the way. There's no square root or radical in the denominator. All right, in letter B, it's going to be similar, only this time instead of having a square root in the denominator, we have a cube root. So it's going to be helpful to look again at your perfect cubes. And I have to think about what can I multiply 9 by so that I'm going to get to a perfect cube. So right away I can recognize that if I multiply by the cube root of 3, that's going to multiply and give me the cube root of 27, which will get rid of that cube root symbol in the denominator. I'm going to also multiply the numerator by the cube root of 3 so that it's being multiplied by 1, this expression here. So when I multiply in the numerator, I have 2 multiplied by the cube root of 3. And then in the denominator, I have the cube root of 27 because 9 times 3 is 27. Again, we do still see that cube root in the denominator, but we know that the cube root of 27 is 3. So that gets rid of that in the denominator, and then the numerator stays the same. So this is my final simplified answer. All right, here are 5 problems for you to try on your own. They are the monitoring progress problems 13 through 17. So go ahead and pause this video, give them a try, and then I will walk you guys through the answers. All right, in number 13, I have 1 divided by the square root of 5. So I'm going to multiply both the numerator and the denominator by the square root of 5, which gives me 1 times the square root of 5 is just the square root of 5 over the square root of 25, because 5 times 5 is 25. This will then simplify to the square root of 5 over 5, and that is my final answer. In number 14, I have the square root of 10 divided by the square root of 3. So I'm going to go ahead and multiply the numerator and the denominator by the square root of 3 to remove and rationalize the denominator. In the numerator, I now have the square root of 30. In the denominator, I now have the square root of 9. There's nothing I can simplify on the top, so the top stays the same. The numerator is the square root of 30, and the denominator simplifies to 3. In number 15, I have 7 divided by the square root of 2x. So I'm going to rationalize the denominator by multiplying by the square root of 2x in the numerator and the denominator. This gives me, in the numerator, 7 times the square root of 2x. Now, this is a little bit different. So in number 14, since both of these were in the square root symbols, I multiplied and kept it underneath the square root symbol. Since 7 is not in the square root, or I'm not taking the square root of 7, that just stays as it is as a coefficient outside of the square root of 2x. In the denominator, I have the square root of 4x squared. And again, in my denominator, I now have perfect squares that can be simplified. So my numerator will stay the same. And then in the denominator, the square root of 4 is 2, and the square root of x squared is x. So that is my final answer. In number 16, I have the square root of 2y squared divided by 3. So I'm going to first just kind of break this apart so I can see what I have. In the numerator, I have the square root of 2y squared. In the denominator, I have the square root of 3. So to rationalize the denominator, I'm going to multiply both the numerator and the denominator by the square root of 3. In the numerator, this gives me the square root of 6y squared over the square root of 9. In the numerator, there's not much I can do, but I do see one perfect square, which is y squared. So the square root of y squared is just y, which will go on the outside. And then the square root of 6 will stay the same. And then the square root of 9 is 3. So this is my final answer. In the last problem, I have 5 divided by the cube root of 32. So again, I'm going to look at my perfect cubes and see 32 times what is going to give me a perfect cube. So I know that if I multiply by the cube root of 2, that's going to give me the cube root of 64, which will get rid of the radical symbol in the denominator. So I'll multiply both the numerator and the denominator by the cube root of 2, which gives me 5 multiplied by the cube root of 2 over the cube root of 64. And as I showed, the cube root of 64 simplifies to 4. And then we have 5 multiplied by the cube root of 2 in the numerator.